second session in data manipulation in Python, and third in the series of data manipulation by Lero. In the first lesson in data manipulation, we looked at how we can use Excel sheets to manipulate data. And in second session, we covered basics of Python, how to set up Python and how to do basic things with Python. In this lecture, I'm going to expand on how we can use Python to manipulate Excel sheets, right? So this should be your introduction to how you can use Python with conventional data formats such as an Excel sheet to draw graphs or manipulate or calculate metrics out of your Python sheet. And before I start, here's a short summary. So my name is Ashish. I'm a final year PhD student at the University of Limerick under the supervision of Dr. Jim Buckley. Dr. Jim took the first session on Excel sheet. I'm a doctoral researcher in Lero, the Irish Software Research Center. Currently, I'm also visiting researcher at the University of California, Berkeley. And I have had a long-term interest in teaching programming to non-computer science professionals and students from non-CS background. I strongly believe programming is fun once you get past a few hoops. You don't necessarily have to go through a graduate level mathematics course to understand how to use programming languages. And that's my whole purpose of these two Python sessions, to show you how simple it is to use Python to do different data manipulation tasks without having to dwell deep into theoretical computer science. So today's agenda. I've noticed there are a few people who did not attend last session on Python, so I'm briefly going to go over what we covered in the data manipulation Python part 1. So that's basically an overview of whatever we covered in last 1 hour session. Then I'm just going to briefly go over how you can write Python code. It's just a recap of what we have already looked at in last session. Then in part 3, I'm going to introduce the Excel sheet. So this Excel sheet was used by Jim in session 1, in which he used Excel to perform different data manipulation techniques. And yes, so the last session has been recorded, and we are eventually going to upload it on YouTube, and we'll definitely forward the link to all the participants. Right, so once we're done with this session, we're going to publish all 3 sessions, including Excel and 2 Python sessions on YouTube. And all of these sessions are linked through that Excel sheet, so it should be easier to follow. Right? And once I have introduced this Excel sheet, we are going to implement basic data manipulation functionalities. Now I'll go through the aims of this particular session in section 4. In section 5, I'm going to give you an overview of different graphing and data manipulation libraries in Python. After that, goal 6 is sort of a stretch goal. This is just to show you that there's nothing to be scared of when it comes to programming in Python. So in section 6, I'm going to use a machine learning technique called linear regression to predict something related to our data set. Now, this should give you a really good idea of how easy it is to use Python, given that we have so many high-level libraries. And after section 6, I'm just going to point out 2 resources that you can use if you would like to further go on data analytics or programming ground. Right. All right, so starting with this session. So this is an overview of data manipulation Python part 1, in case you missed it, or just a short recap. So we'll start with looking at what a variable is, how to declare it, and how to use it. Then we'll look at complex data types, such as lists, dictionaries, how you can read these, how to use predefined functions, and how to use external libraries. So here's a short overview. So what is a variable? A variable is a placeholder to store data in your programming language. It's a really powerful functionality. Variables make your programming language more generic. It can apply to different application domains because they use variables to store data. In this case, I have a very short example. So we have a variable called name, and we have a name inside this variable. Now, all the variables have a data type. In this case, the first variable name is a string. So string is a collection of characters. And usually in Python, we denote string with these quotations. Now you can have single quotes or double quotes, that doesn't really matter. Now, if you run this, you can see that. Let's have a look at data type of name. It's a string. Age is an integer. So the only difference between integer and this fractional value is that integer is non-fractional, it's a whole number. So this is a type of integer. Age, percentage is a type of float. So float is a floating point number. a variable that has a decimal point. It's called float. So programming languages often differentiate between an integer and a float, right? So these are three basic data types that we looked at in last session. After these, we looked at slightly more complex data types such as lists and dictionaries. So the only difference between the basic data types that we looked at earlier and the slightly more complex data type is that these are collections, right? So in case of a list is a collection of different, in this case, numbers, but it can be numbers, strings, or any other primitive data type that we've already looked at. So this is an example of a list. It's pretty straightforward. We use brackets to denote that this particular variable is of type list, right? And accessing your members inside your list is pretty straightforward. Now, this is where your programming language slightly varies from your conventional wisdom. In this case, we don't start reading these numbers from, so in programming, this would be 0th location, this would be first location, second, and third, right? So in order to get the first number, we'd have to pass in 0. So this would print out the first number. So this is something that's consistent throughout almost all programming languages. You start any list or any collection type data structure usually starts from 0. And it's pretty straightforward to access these elements. We use the bracket denotion, and then we pass in a location of that particular element. Now, again, this isn't very intuitive. Just to look at it and understand it starts from 0 to 1. To make it easier to understand, we can use more complex collection types. This is an example of a slightly more complex collection data type. It's called a dictionary. Now, the difference between dictionary and a list is dictionary contains a key value. This key value usually gives a description to your value that you're storing inside this. So for example of a student, this can be used to store different grades for this student. If you're using a dictionary, you know the 74 is referring to grades that this particular student attained in computer science, and so on. So if you run type, it's of type dictionary, right? And how do we access elements inside the dictionary? Again, we can use this bracket denotion, and we can pass in, let's say, computer science. So this should give us number, right? So this is easier to understand when compared to list. So usually dictionaries are more easier to understand and work with than lists, but lists usually perform better. If you're working with a very large data set, you would conventionally use a list and not a dictionary. Okay, so moving on, how do we read data from these collection type data structures? Now, this is the third concept that we covered last week. Basically, the idea is you start with reading first element, then you read second element, then you read third element, and then you read fourth element. In this case, you can easily see that this is a task that you have to repeat over and over and over again. If you're performing a task in a repetitive manner, you can use your programming language to automate that process, right? And we use something called a loop in order to do that. A loop would essentially execute the same piece of code over and over again up until a condition is satisfied. In this case, we have used a very simple loop, which is a for loop. For every result, inside results by subject, we are just going to print result. So this result is a temporary variable. So what this for loop is essentially doing is it's assigning value 74 to result, printing the value 74, and then moving on. In next iteration, it's going to assign it value 38 and print that. So it's essentially just repeating the same process over and over again. This is an example of how loops work in programming languages. Now, in a similar manner, we can use a for loop to read data from our dictionary as well, right? So moving on, we can also use predefined functions. So function, in a very short summary, is pre-written code, a collection of a few programming language code that you can execute whenever you call that particular function. So in this case, we have already used a function called print. The purpose of print function is to print whatever value it gets. So it's just going to print those values to our screen, right? So print is an example of a predefined function. Then we also have another predefined function called type. If you have a variable and you're trying to figure out what the type of that variable is, if it's a string, integer, or float, you can always use this type function. We also have a function called length, right? We can, in last lecture, after looking at functions, we moved on to show how we can use external libraries. Now, We can have multiple functions that perform somewhat a similar task. For example, we may have a function to draw a circle. We can also have a function to draw a triangle. So a library is an example of a collection of different functions that perform somewhat a similar task. For example, we can create a library of different functions that draw geometric shapes. So that's an example of a library. Now, one good thing about Python, since it's used in so many different domains, is that we have a lot of external libraries. So these external libraries, in essence, contains code written by other people that perform some particular task. So you don't have to reinvent the wheel every single time. Now, Python is used a lot in data analytics. So people have to read CSV files a lot, right? So there's already a library called pandas. We can use this library and read CSV files. So this read CSV file is an example of a function that's present inside the library pandas. So now we don't really have to explain to Python how to read a CSV file, how to understand the structure of CSV file, because it's already done. So we don't have to reinvent this particular wheel, right? So we looked at how we can use pandas. Then after pandas, in last lecture, we also looked at how to draw a graph. I'm going to get back to graph in a bit, but just to explain the syntax here, we are going to import an external library called pandas, and I'm just assigning it an alias. So I don't have to rewrite pandas every single time when I want to use a function from pandas. So in this case, I can just use pd.readCSV, right? It's not mandatory to assign an alias, but it's usually a good practice. It helps you keep your code simple. So in this case, we have imported an external library called pandas. We have read a CSV file. So again, in almost all major programming language, your execution starts from right side. It will execute this particular piece of code, and whatever value it gets out of this piece of code is assigned to your student results variable. And then we have looked at how we can read student results variable. And I've just printed this particular variable. So essentially, it's reading a CSV file and printing the values, right? So this is all that we covered last week. So essentially, these are basic building blocks of any programming language. These are not specific to Python, right? Moving on. So how can you write Python code? So what do you need to write Python code? You need a compiler, you need a text editor, and you need a machine to execute that code on. Now, you don't really have to worry about any of these. Since Python is widely used, it's pretty straightforward to set these things up. The easiest way of starting up with writing code in Python would be to use Google Colab. It's a tool by Google. It's free to use. It's essentially Google Docs for your Python source code. You would get access to something called a Jupyter Notebook. A Jupyter Notebook essentially looks like this. You have different cells. So for example, in this second cell, you're allowed to write your Python code. Right, I'm just going to write hello, and then if you hit run button, it's going to execute that Python code. This is essentially what you get in a Jupyter Notebook, and this is what we will use throughout this session as well. Right? So if you're starting up with Python, it's probably easier to use these free tools by Google or Microsoft. For this particular session, I'm using Microsoft Azure notebooks, but just a heads up, they're going to deprecate the service towards the end of this year. So my recommendation is use Google Colab. Again, before you put any sensitive data on Google, you should be aware of your privacy policies related to your company. You do not want to put any sensitive data on third-party computers. If that's the case, and you want to write Python code on your own machine, please follow this last link, jupyter.org. It's a pretty straightforward installation on your machine, and you don't have to rely on third-party sources. If you just want to have a look at the source code that we covered last week or this week, you can always use the GitHub repository. So one good thing about using Jupyter Notebook is that you don't really have to install anything on your machine to be able to look at the source code. So you can always use this launch binder button on this GitHub link that was shared with you, and this should launch the notebook that I'm working with. And you should be able to change this notebook as you wish, right? So you can change this code and explore it. Once you open this binder button, all you have to do is click on the first link on the Jupyter Notebook, and you should have access to the source code. Now you can easily change this code. Okay, getting back to a lecture. All right. So introduction to student Excel sheet. So I have two Excel sheets. This is first one. So this is a fictitious example let's say this is a code for, all right, I have a message, just a second. Yeah, so in this particular lecture, I'm not going to use CSV, I'm going to use a full-blown Excel sheet. So this is a Excel SX file. You can easily convert this to CSV as well. So it doesn't really make much of a difference in terms of how Python deals with these things, right? But I'm going to use an Excel sheet. So this is what I'll start working with. Okay, so this is a fictitious example of a computer science undergraduate level course. We have 40 students, we have 41 students in this course, right? And these are their student IDs, surname, the name, their course, and then we have 3 different types of grades, right? So in this case, the first one is midterm grades out of 30 marks. We have practical grade out of 20, and we have final marks out of 100. Now, this is our starting point, and our end goal is getting this Excel sheet. And we can only use Python to do this, right? So what we have to do, we have different tasks. So the first one is calculate marks for midterm and final exam. So what I mean by calculate marks for midterm and final exam is you can see that midterm grades are out of 30. But in reality, when we calculate our final total marks, that should be out of 100. So we have to normalize midterm grades to 15. So essentially, we just have to divide these scores by half and store them in a new column called midterm by 15. And we have to perform a similar operation on our final exam. In this case, we have grades of final exam out of 100. We just have to convert them, normalize them to out of 65 so that our sum can be 100, right? So that's our task 1. Calculate midterm and final exam marks. Then we have to calculate total marks. So total marks is just a sum of your midterm marks out of 15, your final exam marks out of 65, and your practical exam out of 20. I'm going to revisit these Excel sheets quite frequently, so don't worry if you don't remember all these. Right? Then we have to assign grade to each student. Based on the final marks that you get, we have to assign these different grades. So grades range from A1 to F. Now we have this metric to perform that operation. I'm going to again rehash this metric in a bit. All right. So after calculating grade, we have to calculate ranks as well. So the person with highest total marks should get rank 1 and so on. And we have to assign grades like this, right? We have to assign ranks like this. After that, we have to create email addresses using student ID. So UL specifically has a specified format for student email addresses. So for example, if this is your student ID, your student email address would essentially be your student ID at studentmail.ul.ie. So we just want to create a new string called email and add this particular text. Again, I'm going to revisit these, so don't worry if you don't remember these. Then we have to calculate average score, find mean, minimum and maximum scores. And at the end, we have to plot a histogram. So a histogram similar to this. All right, so we can start working with this Excel sheet. So our starting point would be to read in the Excel SX file. So this is a common example of an Excel sheet saved from Microsoft Excel, right? And we are working with the simplified Excel sheet. Okay, so again, I'm going to use pandas. This is an external library. People have already dealt with reading in Excel files in Python over and over again, so I'm not going to repeat anything there. I'm going to use pandas. I'm assigning it an alias called PD. Again, this is not mandatory. You can always get rid of this part and just use pandas, right? But just so that your code is easier to read, I'm going to assign it an alias. All right. So this, I'm creating a new variable called CSIS9999. That's the module code. I'm going to call a function inside pandas library. This function is called read Excel. So again, you would notice something that the syntax is pretty similar to read CSV file from last week. And there's a good reason for this. So whenever you are using a good external library, they would try to preserve a similar pattern in their code. So if you have a function called read_CSV, you would most likely have a function called read Excel. You would have a function called read text files or something similar to this. So if you're familiar with even a single data manipulation library, you can get most of your work done. Right, so getting back to this, we have created a new variable. We are calling a function called read Excel, and we are passing name of our Excel sheet. So essentially what you have to do is, in the same directory as your Python notebook, you just have to upload your Excel sheet, right? You can use the upload button, and in Google Sheets, again, you can upload them using the web UI, right? Okay, so now once we have uploaded our Excel sheet, we would want to have a look at what our data looks like, right? So one easiest function, one of the easiest function to have a look at your data is to just look at first 5 rows of your data. So I'm just going to hit enter. I've called a function called head. So essentially what this function head does is return first 5 rows. So these are first 5 rows of our dataset, right, of our Excel sheet. Again, we have already read in that Excel sheet to a variable, and we are just calling in this head function on our variable. This head function is going to return top 5 rows. So Viresh, I think the issue related to dependencies is, again, you have to use pandas. Most online IDEs that use Jupyter Notebook already have pandas built in. If they do not, you can always use this pip install command. I've sent in a command. If you do not have pandas installed, you can use this. All right, getting back to our source code. So first step after you have imported your file is to explore your Excel sheet. And to explore your Excel sheet, the easiest thing to do is first look at the structure. I'm using a function called head. This head has written top 5 rows. And I can see I have student ID, I have surname, I have phone name, courses, midterm, practical, and final exam. Right? So this is what the structure looks like. That's good. So we have an idea of what our structure looks like. Now, if you want more details, if you want something statistical about your results, you can also use a function called describe. Now, this is going to give us a lot more information than just head. So you can see that it's going to give us count, mean, standard deviation, minimum, top 25 percentile, and so on. So describe gives you a lot more detail. Like I said, these libraries are used for data analytics, so you can get a lot more done with just a single line of code. Again, I'm not really going to focus much on this at this point, so I'm going to comment on this. Again, first step of any data manipulation in Python would be to have a look at your data, see what your data looks like, what's the structure. Right, so we have read in the Excel file, and now we can start working on it. So our first task was to calculate marks for midterm and final exam. Our simple Excel sheet contained midterm marks out of 30, practical marks out of 20, and final exam marks out of 100. And we had to normalize these values, right? So our target distribution was we should have midterm marks out of 15, not 30. Practical marks were fine, so we don't have to change anything related to practical. And in final exam, we had to change it out to out of 65. So we have to normalize this to 65, right? So I'm going to walk line by line of what I've done, right? And if you get confused, please use the chat feature. Now, again, this is probably the most complex slide in this whole presentation. After this, we are just going to reuse most of the functions that I demonstrate in this slide. So please feel free to ask questions if you have any. Again, first step, I'm going to use pandas. So I'm going to import pandas. I've created a new variable called CSIS 9999. It's going to store my Excel sheet. After storing my Excel sheet, since I've already had a look at the structure, I'm pretty familiar with the rows that we have. Now, I'm going to create a new row called midterm 15, and I'm going to start this row with 0. Set it initially to 0, right? I'm also going to create a new row called final exam out of 65 and start it with 0. At this point, let's see, I'm just going to copy it over to this particular slide. Again, let's execute this. And I'm just going to show that once you run this particular piece of code, it's essentially just going to create 2 empty rows. So how do we explore our data? We can use this function called head, right? So you can see that now we have 2 new rows called midterm 15 and final exam 65, all initialized with value zeros, right? Now, all we have to do is read value for each student, right? read each student's midterm 30 row and divide it by 2 and store that value in midterm 15, right? That's a main logic of this task 1. So that's essentially what I've done in the next step. Again, how do we read the data? How do we repeat a process over and over again? If you have to repeat anything in Python, we easily use a for loop so that we don't have to do it manually. So in this case, for every student inside CS IS 9999, and in this case, I'm going to iterate through tuples. So this is a function that's essentially going to allow me to read each row, read data inside each row, and then move to next row, right? So I'm essentially converting it to a table, and I can read this table row by row by row, right? So that's what this for loop does. So just to show you the output from this for loop, again, coming back to this is our for loop. I'm just going to print student. So this is going to print every single student that's there in our Excel sheet. So you can see now we have a slightly more programming looking structure. So in this case, we have one value that has index 0, has student ID this, and all the values that we knew. So essentially what this particular line does is it converts each of these rows into tuples, right? So there are 2 different functions. The first one is iterate tuples, and then you also have iterate rows. So in iterate rows, rather than creating a tuple, so you can see that this is one distinct entity in your programming in this particular for loop. And then when you move to next student, that's another distinct entity. In iterate rows, if you use that function, it's just going to allow you to iterate through each row and not create a separate tuple for each row, right? So for this particular use case, we can just rely on iterate tuples, right? So we have a for loop for every student present in our CSIS 9999. We are going to iterate through all the tuples, so every single row, right? Now, I've already shown you the structure that we get from student. Now, what we have to do is for our CSIS, this particular data structure for this particular variable at location of student.index. Again, basic idea is for every single student, we are going to read that particular student's entry. We are going to extract midterm marks out of 30, divide it by 2, and save it into midterm marks out of 50, right? So what we're doing is using this index. So in this case, we have, for first student, we have index set to 0, right? If you have index set to 0, it's just going to open this file, look at student at index 0, and look at the field midterm out of 15 and give it a new score, right? So essentially, it's going to look at each student, look at their midterm score, divide it by 2, and then change the value of this Excel sheet, right? So the workflow is you start reading from right side for each student in their midterm marks, you divide that marks by half, you change your CSIS file, this particular variable, and update that value. And you can see the updated value there. So I have a few messages in chat. I'm going to respond to them now. No module named pandas when running import pandas as PD. So if you get errors related to dependencies, for example, external libraries, the easiest thing to do in that case is to use something called pip. So pip is Python's way of installing external libraries. So this is, I'm going to send, okay, I can show this code here, right? So the idea is you can use pip to install pandas on your machine, right? And if you execute this, it should install pandas on your machine. Right? If there are any missing dependencies, please feel free to use pip. You can almost always get most common libraries through just a single line of code. You don't have to worry about any dependencies. So that should solve your issue of no module found pandas. All right. So second is, what if we don't use iterate tuple? What will be the difference? Performance degradation. So now this is, I'm going to answer this question, but it's for people who are worried more about performance. If you're worried about performance, you should not use data frames, right? Data frames are not really good in terms of their performance. You would use something called NumPy arrays. NumPy arrays are very good in terms of their performance. So if you have a very large data set, I would not recommend using pandas. In that case, you would use NumPy and then iterate through values. So iteration through data frames, if you have a very large data set, is not a good idea. But in this case, since we don't have a massive data set, we can go on. And the purpose of this particular slide is just to show you that it's really straightforward to do, right? I'm going to get back to what NumPy is and how you can use it in a bit, right? So moving on, I hope this particular line is clear, right? So we have a for loop for every single student. We are going to read every single row as a tuple. Once we started reading that particular row, for each student, we are going to get the midterm score out of 30 divided by 2. So this should give us a new integer or float value that we are going to assign to our CSIS data frame, right, at the index location for this particular row. So when you use Python, you don't really have to worry about giving it a range. If you use Excel, you know you have to give it a range and you have to make sure that particular range is valid. But in case of Python, you just have to give it a row or column name. In this case, I have given it a column name, and it basically just divides for every single row, assign it to that particular column for this particular student. And each student has its own index, right? Okay, I hope that's clear. Now we can essentially repeat the same process for normalizing grades from out of 100 to 65. That's exactly what this line does. So it repeats the same process. And at the end of this particular for loop, we have a new data frame that has two new columns, midterm marks and final exam marks, right? So I hope that's clear. We are just going to reuse these concepts over and over again in the next few slides. So if you have any issues, please feel free to ask me at this point. All right, so we can move on. Now we have to calculate marks for final exam. So how do we calculate marks for final exam? First step is create a new column called total marks. Initialize this new column to 0.0. So we have created a new column that takes in float values. After you have created a new value for every single student, we are going to iterate through tuples, so every single row. We are going to get the midterm marks, we are going to get practical marks, we are going to get the final exam marks, add all of these values and assign them to this new column called total marks, right? So once you perform this step, you have calculated total marks. It's pretty straightforward. So the first step is creating a new column, then extracting existing values from each tuple. In this case, we have extracted these three values, we have added them up, and we have updated our CSIS 9999 data frame. So if you're confused about what a data frame is, so a data frame is a variable that's specific to pandas. So pandas don't really use dictionary or list, they use something more complex. It's called data frame. You don't really have to worry about internal dynamics of how data frame works, but essentially it looks like an Excel sheet. That's what we are seeing here, right? All right, so I hope there are no doubts at this point. We are essentially just repeating same steps over and over again. Okay, so I'm going to move on to task 3. Now this is slightly interesting. This is something that we have not done so far. We have to assign grade to each student, right? So at this point, we have taken in our Excel sheet, we have performed some mathematical operations on that Excel sheet, and we have ended up with a new field called total marks that has final grades for each student, final marks for each student. Now we have to assign grades. And this is the schema that we have for grade assignment. Basically what this means, if a student has scored total marks 80, we have 80 or greater than 80, we have to assign this particular student A1, right? So essentially we have to check every single total marks and see if it fulfills some condition. If it fulfills that particular condition, we have to assign it a grade. If it doesn't, then we have to perform some other operation. Now, this is a very common issue that you come across when you're trying to deal with computational problems. And there's a really easy way of dealing with this, right? So I'm just going to demonstrate how to use something called an if-else statement. So these are conditional statements. Essentially, let's say, this is a very simple example. I have a user called John, and John wants to see a movie. but he can only see that movie if his age is over 18. But in this case, his age is 12. So now we just want to see if John can watch that particular movie. It's a pretty straightforward process. If John's age is greater than 18, we should allow John to watch that movie. So I'm going to use a print statement and say you can watch this movie, right? So first part of this conditional statement is if your age is greater than 18, you should be able to watch this movie. But if your age is not 18, then this is else part of the statement. So it's going to look at if condition. If the if condition is true, it's going to execute this code. If the if condition is false, it's going to come down and execute the statement. No, you cannot watch this movie, right? So if I execute this, you can see that since John's age is 12, he cannot watch this movie. If I increase this age to, let's say 24, he can watch this movie. So that's the basic idea behind if-else statements. So these are conditional statements based on result of this condition. It's going to either print this value or it's going to print this value, right? So basically an if-else statement. It's going to execute these conditions based on results. It's going to perform some task. Now that's essentially what we are going to use in this case. We are going to read in total marks, in this case 80. And if we are going, then we have a bunch of if-else statements that are going to check if the total marks is equal to or greater than 80. If it is, then we are going to assign it a score of A1 and so on, right? All right, so here is an example. Now, I know this may look overwhelmingly complex, but it's pretty straightforward. It's just a bunch of if-else statement cascaded. Now, here is how this looks like. Okay, so I'm just going to go through first few if-else statement and then it's just a repetition. So again, first step of doing this is creating a new column called grade, and I'm going to assign a value of string NA to this particular column. Again, this column is always going to contain a string, so I've initialized it with strings. Now for every single student, I'm again going to iterate through tuples. We have already looked at this. If student's total marks is greater than or equal to 80, I'm going to print this, right? Sorry, I'm going to assign A1 to grade for that particular student. I'm going to change this value inside our CSIS data frame, right? If this condition is not true, then it's going to get into else statement. But inside this else statement, I again have an if statement. So if this isn't true, if the student has less than 80 marks, we are going to evaluate this if statement. And in this case, we are just checking if it's greater than 72, greater than or equal to 72. If it is, we're going to assign this grade, else we'll continue to go on, right? So that's the whole idea behind if-else statement. And you can make really complex if-else statement. Now, this is by no means the most ideal way of dealing with this situation. There are better ways in Python and other programming languages to deal with this type of if-else statement. It's called a switch statement, but I'm not going to cover that since it's just an introductory lecture. Basic idea is, in programming languages, you have the possibility of checking condition and based on output of that condition, perform some operation. Easiest way of doing that is an if-else statement, right? So this is what our output would look like. In this case, final exam score for this particular student is 32 total marks is 54. So we have assigned grade C1. Now this is all automated, so it doesn't really matter if you have 50 students or if you have 1,000 students, it's going to automatically perform this operation. All right, so I hope we are all clear on if-else statements. And again, you have access to these sheets, right? You have access to this piece of code. So please feel free to change this code and see the output for yourselves. The easiest way of learning a programming language is just by practicing, just by changing code. Okay, coming back to this. Now, after getting the grades, we also have to calculate ranks for each student, right? Again, this is the final output Excel sheet first, and you can see that there's this field called rank. So the person with highest total marks should have rank 1. Now, rather than creating a complex formula like this, you can see this formula. in Python, there's a really easy way of doing this. So we are going to create a new column called rank. And in this new column, we are going to give it value based on total marks column. We are going to rank different values. We are going to calculate ranks, and it's not going to be an ascending. So it's a descending order, right? That's pretty much it. This is a very straightforward way of calculating ranks. It's going to assign rank to people. Now you can see these ranks are given in float values, but they have a 0.0, but it doesn't really matter since our total, in our total marks, we are always going to just have a single value. So you can easily convert these to integer, but it doesn't really make much of a difference in our use case. So the idea is your pandas data frame have a lot of built-in functionality that you don't have to code. One of these examples is a rank. So you don't really have to code rank. You can just say that please calculate rank based on total marks column of this data frame and make sure it's not ascending. That's it. So you have a new field called rank inside your data frame without actually worrying about different columns of fields, right? So we're done with calculating rank. Great. Moving on. Now we have to calculate, we have to create email addresses using student ID. So like I said, UL has a predefined format of creating student IDs. So the basic idea is you take your student ID and just add this string to it, add studentmail.ul.ie. Now, why would this be useful? So for example, I can use my Python script to create these email addresses and also send emails for me. Now, Python has different external libraries that could automatically send these students email with their grades breakdown. So you don't really have to, you don't have to do it manually. You can automate this process using Python. So that's just one example. Now, how do we do this? Again, we are going to create a new column called email. I'm going to initialize it with an A. So that means not available. Now, based on for each student inside our data frame, we are going to iterate each tuple, so row by row. So let's start with right side. I'm going to create a string out of student ID. So as of now, this field student ID is an integer, right? We have to convert this integer to a string. Now, how do you convert an integer to a string in Python? You just call a function called string. Now, strictly in programming language terms, we would call this type casting. So the basic idea is you convert a data type from one data type to another one. So this is called a type casting. You don't have to worry about it. The basic idea is use this inbuilt function called string, pass in your integer, and it's automatically going to convert it to a string. Now, after that, I'm just going to add this piece of string. That's pretty much it. I'm going to assign this value to the column email for every student using their index. So for 0th student, I'm going to get student ID, add this string, and assign this value to email addresses column. That's pretty much it. So that's done. You don't have to worry about anything else. All right, moving on. So step 6, calculate average score. Just like Excel, Python has a lot of useful inbuilt functions such as mean, median, standard deviation. So we don't really have to worry much about it. So now if you wanted to calculate average for average of total marks, you can just use your data frame, look at column total marks, use the function called mean, and it's going to give you a mean, an average, right? So that's pretty straightforward. We have already calculated mean. Now, an interesting use case, right? So let's have a look at this Excel sheet. So we have different courses. Students are assigned, students have different courses. So in this case, we have 4 different courses for each of these students. Now, what if I wanted to calculate mean based on different courses? Now, Python has a really easy way of doing that as well. You look at your data frame, you use a group by statement. So essentially, it's going to group different values in your data frame based on their entries for value course. So it's going to keep people in computer science, computer systems course as a single unit. And it's going to return a single value for people in computer systems. And after that, we are just going to look at total marks, calculate mean. That's it. If you look at your results by courses, computer systems have 50%, so we can see media technology students have on average scored higher grades than other students, right? Pretty straightforward. You can use a group by clause to do this. Okay. Moving on. We can also find minimum and maximum scores for students. Again, pretty straightforward. Use your data frame, look at column total marks, use dot min method to get the minimum value, use dot max method to get the maximum value. In this case, you can see that I've created a slightly more complex print statement, and the reason for this is to make our output more easier to understand. What I've done is I've printed a string called minimum. Min equal to, this is a string. I'm going to print this string, and after that, I'm going to print value from my data frame. So you can essentially use your print statements to create more informative outputs, right? Now, again, I can calculate min and max values depending on courses as well. In this case, you can see I've calculated minimum and maximum values based on courses. In this case, this prints the minimum value for each of different courses. So again, I've used a group by clause. All right. Plot a histogram. So if you remember from last session, we looked at something called a library called matplotlib. Now we have imported matplotlib. So matplotlib is a fairly complex library. And if you include every code written in this library, it may slow down your execution. In this case, I'm just worried about Python plots. So I'm going to only import Python plot part of matplotlib. I'm going to use an alias called plot. So you can see why aliases are useful at this point, right? This is a fairly long string that we have to reuse over and over again. So we can just give it a small alias and use that. So we're going to plot a histogram. So how do you plot a histogram? Just use this alias plot and call method called hist. This stands for histogram, and pass in our data frame. In this case, our data frame CSIS, we only want to get a histogram for total marks. So pretty straightforward. Look at data frame CSIS column total marks and create a histogram. So what essentially histogram does is give us frequency in ranges. So in this case, we can see that there's only one student who has gotten between 80 to 90 marks because the frequency is 1. Now you can easily make this more informative by adding X labels and Y labels. That's pretty straightforward. I'm not going to get into depths of how to use matplotlib, but that's essentially how straightforward it is to draw histograms or any other graphs in Python, right? Okay, so we have 8 more minutes. I'm trying to, I'll try to cover the machine learning part just to show you how straightforward it is, and then I'm going to conclude this session. All right, so here's a short list of different libraries that you should look at once you're done with this session. We have already looked at pandas. It's very useful for handling tabular data, for example, CSV or Excel sheet. But like I said a while ago, these are not, pandas is not known for being good in terms of performance. If you're dealing with millions of rows, using pandas data frame might not get you a useful output. So in this case, you should use something called NumPy. So NumPy stands for Numerical Python Library. It's designed to be good in terms of performance, right? So if you're dealing with a very large data set, use NumPy. NumPy integrates really well with pandas. So if you know a few functions in pandas, you can easily use them with NumPy as well. So these pandas and NumPys go hand to hand in data manipulation. I've only covered pandas just to show you how these things work. For graphing libraries, we have matplotlib. I've shown you 2 demonstrations of how to use matplotlib. It's good for most basic graphs, but it tends to get slightly more complex in terms of the syntax. So by syntax, I mean you have to write somewhat complex syntax to get basic things done. So there's a really good library called Seaborn. It's built on top of matplotlib, and it's really useful if you're dealing with data frames, and it has a very simple syntax. So you don't have to memorize complex syntax for matplotlib. If you're new, you should also look at Seaborn. It's a pretty straightforward library. For more data analytics, you should look at scikit-learn. So basically, it's a scientific library for Python that performs a lot of statistical operations. I'm going to use scikit-learn to show you a very simple example of machine learning model in Python, right? Since I'm almost out of time, I'm going to carry on without a break at this point, right? Okay, so this is an example of predictive analysis in Python. I'm going to use something called linear regression, right? I cannot delve deep into mathematics of linear regression, but the basic idea is, so let's think about our use case, right? So this is the Excel sheet that we have so far. And I wanted to see, based on midterm scores of students, how many marks they would most likely get in their final exam. Is their midterm score a good predictor of their final exam? So use machine learning to take in your students' midterm grades and predict their final marks, right? So what linear regression does is, on x-axis, for example, it has your midterm grades. On y-axis, it would have your final grades. And essentially, it's going to find a common line between these two, right? So basic idea is, try to, so you can see that there's obviously a trend, right? If you move higher in your midterm exams, you also move higher in your final exam. I'm going to show a better screenshot of this in a bit. So let's just have a look at this, right? So I've plotted this using our own data set that we have been working so far. On x-axis, you have midterm marks. On y-axis, you have final grades. We can easily see that there's a pattern. If you get higher marks in your midterm, you would likely also get higher marks in your final exam. So linear regression, it's a machine learning technique that essentially tries to identify these patterns. So what it's going to do is draw a straight line that's really close to almost all of these points. So the idea is, draw a straight line that is on average closest to all of these points. Right? That's what this graph demonstrates, a straight line that is on average closest to each of these points. Now, next time when we encounter a value of midterm that we have not seen before, we can just predict a value using this straight line. Okay. Now, if you have not understood the mathematics behind linear regression, don't worry, it's slightly more complex than this, right? Okay, so how do we use linear regression in Python from whatever we have learned? So I'm going to use pandas, again, data frame, to read in our Excel sheet. Then I'm going to use matplotlib to just plot graph. Now I'm going to use scikit-learn. So this is scikit-learn library that I was initially talking about. And for example, let's look at this line. So I wanted to perform linear regression, right? So scikit-learn has a section on linear model. So rather than importing the whole library scikit-learn, I'm just going to import linear models. And from linear models, I'm just going to use linear regression, right? So rather than importing thousands of lines of code, I'm just going to import code relevant to me, which is linear regression. Now, since I don't really have a lot of data to test this particular machine learning model, I'm going to use my input. So in my input, I have 41 students. So essentially, I'm just going to divide, let's say 40 of them will be used for training my machine learning model. And in last 4, I can test how good or bad my machine learning model is, right? So first 40 will be used to train my model, and last 5 will be used to test it. So basically, training my model is just teaching your machine learning model how to draw that line, right? Moving on. Okay, so this is pretty much it. This is an example of a machine learning model predicting values in Python, right? We have already looked at this line, so we are going to use linear regression. Now to split my input file into test and training data set. So why do we need 2 different data sets? We can train our model using the data that we have already looked at, but we also need to know how good or bad this particular model is performing so that we can make it even better, right? For that purpose, we split our input file into train and test. In order to make that process of splitting easier, we are going to use a library, scikit-learn. From this, we are going to use a subsection called model selection. And from that, I just need training and testing split function. So this is a function that's going to split it for us, right? Okay, so in x-axis, I'm going to assign values of midterm marks. On y-axis, I'm going to assign value of total marks. Now, machine learning models are not really nice in terms of how they deal with data frames, so we have to convert this to a vector. I'm not going to get into details of how vectors work in Python, but essentially it's a single row data rather than having rows and columns, right? So I'm going to reshape this data and create a single column. And in a similar manner, I'm going to create y value. And after creating this, I'm going to use this method, train test split, the method that we imported earlier. pass in our x-axis. So on x-axis, it's midterm values. On y-axis, it's total marks. And it should use 20% of my data set to test it, right? Don't worry about random state. The idea is random. If you set a random state value, it's always going to give you same output so that you can debug it. But as of now, don't worry about it, right? So this particular function is going to return 4 values. It's going to give us x train data set. It's going to give us x test data set. It's going to give us y train and y test, right? Because we have 2 values. We have x value, we have y value, and we are going to split it into testing and training data set. So we end up with 4 values. Now, the easiest part of this all, we're going to create a regressor. So basically, this is again a variable, right? It's a variable that's going to call this function called linear regression. Where do we get definition of this function? From our scikit-learn. Now I'm going to call a function inside regressor called fit. So this is where we train our model. This is where we are training our machine learning model. For training, we need to use x-train and y-train. So x-train is your midterm scores and y-train is your total marks. This will train your machine learning algorithm. Then we are going to make predictions. How do you make prediction? Use your regressor, call a method called predict, pass in your test data set. And then I'm going to print the value. So here's the output, right? So this is the test value. And this is the predicted value. So you can see that it's pretty close, right? The actual value was 80.45 and our model predicted 72.30 and so on. So we can see that this model performs fairly well. There are different metrics of saying how good or bad your model is. But my whole purpose of showing this demonstration is to show you how easy it is to use machine learning models in Python, right? That's it. That's a linear regression model. Now, if you want to look more at the data science side of Python, you can have a look at Kaggle. And if you want to learn more about how to program better in Python, you can have a look at W3 schools. And that's pretty much it. If you have any other questions, please feel free to ask me. There's a question about, do you plan on organizing other seminars related to predictive analytics with Python? We're thinking about organizing more sessions on machine learning in Python. So that's in the pipelines. We might organize it during the winter break. But as of now, we don't have an absolute date of when we might organize that. If you have any other doubts, please feel free to let me know. My whole purpose of these 2 sessions was to show you that there's absolutely nothing to be scared of when it comes to Python. You have a lot of libraries. Most of the tasks that you would ever want to perform have already been coded down for you. You just have to call those methods, right? So that concludes the second session. Again, feel free to work with these different notebooks that I have given. These are on my GitHub. You can use them. You can manipulate the code. If you ever get stuck, my email address is on these files as well. So please feel free to send me an email. That's it. Thank you very much for attending this session. I hope you have a good day.